We are going to be looking at subsets, intersection, union, and complement of sets. Now, given a universal set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we are given another set A equals 2, 4, 6, 8, and 10. Now we say A is a subset. Now this is the symbol we use to represent subsets. It's like a C, but it's elongated. Okay, so A is a subset of U. Why? Because all the elements in A are found in U. So 2 is here and 2 is here, 4 here, 4 here, 6 here, 6 here, 8 here, 8 here, 10 here, and 10 here. So all the elements in A are subsets to the universal set U. So let's say there's another set B which is equal to 1, 5, 9, 11. Now this B is not a subset of U. Why? Because 11 is in B but not in what? U. Therefore B is not a subset of U, since all the elements or members in B are not in U. So that's the difference between a subset and not subsets. Now we have another question that says if P equals 3, 6, 9 and Q equals 1, 3, 5, 7, 9, find P intersection Q. Now to be able to find P intersection Q, first of all, let's list the elements properly. So we have P equals 3, 6, and 9. And we have Q equals 1, 3, 5, 7, and 9. Then P intersection Q is going to be equal to, we look for the elements which are in Q and are also in what? P. The elements in P and Q. So looking at that, you can see 3 here and I can see 3 here. So 3. Then I can see 9 here and I can see 9 here. Therefore the P intersection Q is 3 and 9. Now we have another question that says if A equals X is such that X is greater than or equal to -2 and B equals X is such that X is less than 5, where X is an integer, find A intersection B. Now this is super easy, and what we need to do first is to list the elements of A and B. So let's find a solution. A is equal to, now from the question we know that X is an integer, therefore we are going to list all the integers greater than or equal to -2. So we start from -2, then we move on to -1, then 0, then 1, then 2, 3, 4, 5, 6, 7, 8, and so on. Then we move on to B, then we move on to B. B is going to be equal to, now from here we can see that we are supposed to list all the integers less than 5. Therefore all the integers less than 5 include 4, 3, 2, 1, 0, -1, -2, -3, -4, and so on and so forth. So what is A intersection B going to be? So we look for the integers that are in A and in B at the same time. So going through the list, you can see that 4 and 4 matches. Okay, So from here, A intersection B is going to be equal to, let's see, so I'm seeing 4 here and I'm seeing 4 there, so I write 4. Then I'm seeing 3 here and I'm seeing 3 here, so I write 3. Then I'm seeing 2 here and I'm seeing 2 here, I'm seeing 1 here, I'm seeing 1 here, I'm seeing 0 here, I'm seeing 0 here. So at least you can write those ones. So 3, 2, 1, 0. Then I'm seeing negative 1 here and I'm seeing negative 1 here. Then I'm seeing negative 2 here and negative 2 here. So that's going to be equal to negative 1 and negative 2. And these ends are set. Therefore, the elements of A intersection B are 4, 3, 2, 1, 0, negative 1, and negative 2. And this is descending order. If you want to rearrange this in ascending order, then you can start from negative 2, negative 1, 0, 1, 2, 3, and 4, and it is still correct. Now, the opposite of intersection is a disjoint set. So let's say you have a set P equals 2, 4, 6, and 8. And let's say you have a set Q equals 1, 3, and 5. Now, in this set, you cannot find P intersection Q. Why? Because there's no number that is common between P and Q. Therefore, this is an empty set. Or you can use this notation to mean empty sets. Now, we are going to learn something concerning the union set. If you have a set Q equals 7, 8, 9, 10, and a set R equals 5, 6, 7, and 8, then our Q union R is going to be equal to, now it's a combination of every element here minus those that repeats. So we start arranging them. So we can see from here, you can choose 5 here, 5, so write the 5. The next smaller number is 6, then we choose our 6. The next one is 7. You see, you have 7 repeating twice, so just pick 1, 7. Then 8 also repeating twice, so we just pick 1, 8. And then we have 9, and then we have 10. So this is what union is all about. Therefore, Q union R is 5, 6, 8, 9, and 10. Another example of the union is find A union B if A equals 6 less than X less than 12 and B equals 4 less than X less than 9, where X is an integer. Now this is super easy. All you need to do first is to list all the elements of our A and our B. So we go ahead and do that quickly. So our A solution, our A is going to be equal to, you can see since X is an integer, we are only writing the numbers between this 6 and this 12 without this 6 and this 12 being included because of this symbol. This symbol, there is no equal to under it. This one too has no equal to under it, like this. If there was an equal to like this and like this, then these numbers are going to be what? Included. But we don't have anything like that. So we start from 7 to 11. So A is going to be 7, 8, 9, 10, and 11. Then we move on to list our elements for B. Our B is going to be equal to, so we look at the intervals and then we list the numbers in between. So that's going to be from 5 to 8. because 4 is not included because there's no equal to under here and under here, so we don't what add those numbers. So you're going to have 5, 6, 7 and 8. Therefore our A union B is going to be equal to 5, 6, 7, 8, 9, 10 and 11. And we can rewrite this as a set builder notation as A union B equals, well, now where does the number start from? 5. It starts from 5 and ends where? 11. So we write our 5 and 11. Okay, then we know that x is greater than or greater than 5 but what, less than 11. So put the equal to sign here and another equal to sign here to show that the 5 and 11 is included. Now this is another example of finding union. In this diagram we are supposed to find A intersection B and A union B. So what is it going to be? So we can see that our intersection is this region here. So the elements in there are what? 3 and 4. So we write 3 and 4 for the intersection. Then for the union, we need to write all the elements in both A and B, and that includes 1, 2, 3, 4, 5, 6 and 7. Okay, they are coming from here. 1, 2, 3, 4, 5, 6 and 7. So that is how to find the union and intersection from a Venn diagram. Now take a few seconds and read this question. This shouldn't take you more than 20 seconds. Okay, so how do we actually solve this question? First of all, we must list all the elements of P, Q and R. It says P is a factor of 16. So we go ahead to list the factors of 16. So our solution, so P equals, what are the factors of 16? That's 1, 2, 4, 8 and 16. And the next set says Q is a multiple of 4 less than or equal to 16. So multiples of 4, so Q equals what? Multiples of 4 less than or equal to 16. So we start 4, 8, 12 and 16. You do not cross it because the question says it should be less than or equal to 16. The next one is R, and R is between 11 to what? 16, and we assume that R is an integer. So R is going to be equal to, so now that we know that our R is between 11 to 16, we start 12, 13, 14 and 15. So these are the elements we have here, and it says you should find I, P intersection Q. So our I, P intersection Q, this is going to be equal to, now look at the elements of P here and Q here. Okay, so what elements are common? I can see 4 here, I can see 4 here and 4 here, so I write down 4. The next element I'm seeing is 8 and 8, so I'm writing down 8. And the next element I'm seeing is 16 and 16, so I'm writing down the 16. So II says you should find P union Q. And how do we find it? P union Q. So we start arranging them in ascending order. I can see 1, so I start from 1. The next one is 2. The next one is 4. The next number is 8. The next number is 12. The next number is 16. Then we are done. That is the union, combining both elements in the set. And the next question says we should find P intersection R. P intersection R. So we are looking at this P here and this R here. So the elements between them is what we are interested in. So P intersection R is going to be equal to currently there are no elements in P intersection R, so it is an empty set, or this. So let's move on to our next question. I says P intersection Q intersection R. Do we already, first of all, we need to solve the bracket first. Do we have Q intersection R already? We need to find that. When we find that, then we intersect it with what? This over here, P. Okay, so that is our strategy. So our Q intersection R is going to be equal to, so this are Q and these are R. So the intersection, I'm seeing 12 only. So now that we are done, we need to find P intersection Q intersection R. But mind you, we already know that Q intersection R is equal to this 12. Okay, so where is our P? Our P here, the element here. So Q intersection R intersection that, you can see 12 here, but we cannot find any 12 here. Therefore, this is also an empty set, or this. And the next one says we should find, or the last one says we should find P intersection Q or intersection R. So first of all, we need to find P intersection Q. So P intersection Q, this is going to be equal to, now let's look at the elements of P and Q. That's this over here and this. So I can see 4 and 4, 4 and 4. I can see 16 and 16. I can also see 8 and 8. So therefore 4, 8 and what? 16. So we go and rewrite that over here as 4, 8 and 16. Now we are not done. They are saying we should find P intersection Q or intersection R. So we need to intersect all we are seeing over here with what? R, this set here. Okay, intersection Q or intersection R, and this is going to be equal to, yes, I'm seeing 4 here, but I don't see, I'm seeing 4 here, but I don't see any 4 here. I'm seeing 8 here, but I don't see any 8 here. I'm seeing 16 here, but I don't see any what? 16 here. Therefore P intersection Q intersection R is also an empty set.